So there are lots of things behind the scenes that I made this file. One of which, though, is an angle I've called A in here. And if I just make this visible as a little slider, this angle, which is currently 4 degrees, controls the angle of this vertical, it's not quite vertical, line from vertical. So if I make this a lot more skewed, you can see that I'm just cutting the shapes up in a different way. But the same way, just the result is different. And now I think to sort of like rumble it all is if I spin each of these shapes now, the same thing happens. Notably, these lines line up. I'm not shifting them out, or at least they do for this one. If I spin that one, I hope you noticed that although that line lines up, that one doesn't. And if I spin all of them now, and the correct response, if I'd shown you like this, would be, well, so what? You've moved some pieces around. Hey, actually, it's a proof of Pythagoras. In fact, it's called Perigol's dissection of a Pythagorean proof, if you like, and that's worth looking up, Perigol's dissection. But the big reveal is that when I spin them, I don't make the same square size. Of course I don't, because there's a big white square in the middle. But when the skew angle is small, the difference, if I go back down to like a 4 degree thing, let's leave it at 4.5. Difference between not having a hole in the middle and having a hole in the middle, actually the square has changed size, but it's changed by that white area spread all the way around this shape so that it's almost invisible. And there are lots of other puzzles like this where you rearrange some shapes and then a missing square appears or disappears. Martin Gardner calls them Curry paradoxes, which is a shame because apparently there's another Curry paradox in logic which is entirely different. But there was a magician called Paul Curry, I think, who came up with one of these that was nice. This one's on the wiki. If you search for missing square puzzles, there's an animation of this on Wikipedia. And what I like about it is that the squares are different shapes, different sizes. That's the only reason it works. But it's so not obvious that it becomes almost a magic trick. And so it becomes an example of what we assume as mathematicians. I think if you see this and you think, well, all the squares are the same, all the square pieces, all the quadrilateral pieces are the same area, which they are, then surely the square must be the same area. And it looks like it is, but it's not because I've chosen a small square in the middle.
Can we just go to 45 degrees just to
let's go all the way.
Extreme.
Oh, what a lovely mathematician thing to do, Gord. Test the extremes. Like that's such a good example of what mathematicians do. Yeah. So there are the two different squares. In fact, one is, I think, root 2 times bigger than the other, is it? Because I'm making the edge of the left-hand edge there become the edge of the inside square. So that inside square is precisely the same as what I started with now. And then these other bits go on the outside. But anywhere in between, and, well, actually, the first thing that I put this on Twitter at the weekend, and a lot of people were like, what is going on? And I had a lot of mathematicians talking about the shapes in the corners, particularly when the angle is small. If we just look at this shape that's now spinning, what shape is it? It's surprisingly not obvious. So I had a bunch of people telling me it was a kite, and I wonder if you agree. And they were justifying it by saying that is a right angle, and the opposite side there is a right angle, which it is. And suddenly, well,
it's not a kite.
No, it's not a kite, because also the opposite angles being the same is one part of a kite definition, but you also need adjacent pairs to be the same, and that's not true in this case. Other people were telling me it was a trapezoid or a trapezium, and the trouble with that is that it depends which part of the world you're in as to what that means. And I knew this, but fell into this with a bang. In Britain, I would say that's not a trapezium, and a trapezium is a shape with parallel sides, one pair of parallel sides. I'm just going to dodge the debate of whether it's exactly one pair or not. Let's not go there. And apparently in North America, you'd say the same thing about a trapezoid. Is that true? A trapezoid is shaped with a pair of parallel sides.
And that is not a trapezoid.
No, it's not, because none of the sides are parallel. None of the opposite sides are parallel. So it's neither a kite nor a trapezoid. But the maths teacher that made those comments on Twitter, she was just trying to think through the ideas, and fair play to her. She made a very interesting observation, is that she has been so working with school maths all the time, where you never consider a shape that's not like a square, a rectangle, a trapezium or trapezoid or parallelogram or a kite. How often have you ever sat down and analysed the shape of a non-regular quadrilateral that doesn't have another name? In fact,
we need to name this. Like, Ben,
well, I think
you name this. Like, this has got two sides of the same length that touch at a right angle, and then the opposite angle is right as well. Like, there's got to be a name for this, Ben.
Well, this is where I fell into the North American versus British convention, because what we call a trapezium, which has one pair of parallel sides, apparently the word trapezium, if it's used at all in North America, means not quite one of these shapes, but a shape with no pairs of parallel sides. And the opposite, according to Google, a trapezoid in Britain means a shape with no pairs of parallel sides. So basically, whatever you call this shape, it's not the one you call the one with parallel sides. Apparently,
but I always want my students to be looking for something in a shape, that some symmetry, and here there is information. There's information that you're not getting if you're just saying, oh, this is just one of those other ones that's not all of these. No,
so you're right.
Something special.
And it does have something special, which is particularly the opposite pair of right angles. So I'd be tempted to use that as my focus of a name. Maybe let's say in North America, where most people are watching this, a trapezium means a shape with no pairs of parallel sides. Let's just say that, although Brits are now kicking off over here. Maybe I'd call this a right opposite trapezium.